Let's start with company update.
Yeah, more back and forth on the AMD contract. I think we'll talk about it in this meeting. I don't, it's so difficult to work with these people. It's like, is this a priority for you or not,
Okay.
Yeah, I mean, I don't know. We'll see if that happens, but yeah, I don't think we should spend too much time thinking about. The contract would be for 4 or 5B Llama on AMD's new hardware. If they come through with it, but it's just it's so like you don't know anything about what's true. They don't show you any of their. Now it's in legal review. Like what?
Yeah.
Why? I don't get it. What does this have to do with legal?
Of course, it has to do with legal.
Why? We're not getting anything. Like something I'm really concerned about in general is like you never want to. So you see so many people. Like this is how I feel about like using like React and Kubernetes, right? Like if you use these things, you become Meta or Google. There's the app's a Trojan horse, and like this sort of mentality is a Trojan horse too. Like you start thinking about it and interacting with this kind of thing, and then you just become this.
I think having a lawyer looking over your contract makes sense.
Well, yeah, sure, but like, oh, it's illegally. I don't know. So I'm lowering to a 50% chance this contract goes through.
No, I think legal review is pretty serious. I'll give it a higher chance if it's really like just a legal review.
But is it even true? Like,
Oh, of course.
Maybe. I don't know.
Okay. Anyway, we should get we should see if this is happening anyway soon.
Again, I'm this close to saying no. When you guys are serious, come back and
Yeah, but that's you. I don't know.
Like actually, when you're serious, come back to me with something. When you're serious, here's my wiring info. Wire me the money.
Yeah.
So. No, it's just like you don't want to start. We don't need the money. You don't want to start like letting this behavior into your company.
I mean, it's not like we are doing legal review.
I understand. I understand, but really at arm's length, because like this stuff comes in and it just corrupts your company, and you see how these things become so ineffective. I say that like my job at Comma is just to keep all the bullshit away.
Yeah, but also Comma or Tiny is not a public company, right?
No, but I mean that's not even the point, right? It's like you want to do legal review, you do all of that before you talk to me. That's your problem. I don't want to hear about this. Like you come to me, you want to contract us? Okay, you come to me with a contract. Make it ready to sign.
Yeah. But didn't we also ask for revision?
Well, yeah, but like we asked for like 2 lines to be changed. Right, it's been a week. I just don't think they're very serious. I don't think we're gonna end up working with them.
I see. Okay.
Yeah. No, I'm gonna say if this isn't signed, if the money's not in our bank account by next Monday, I don't think we should waste any more time thinking about this.
Okay.
Yeah.
We get Tinybox cases.
No, we didn't get the Tinybox cases yet either.
I heard it's in the mail. It's not in the mail
today. Well, okay. There's 2 sets of cases in the mail. There's one in the mail by DHL, and there's one in the mail by FedEx. They were shipped on June 7th by DHL. I don't know why there's no tracking number here, but it says ETA end of last week, which didn't happen, or the beginning of this week. And then the other one, shipping by FedEx, I have a tracking number for, and it is in Memphis, Tennessee.
Great. Sounds pretty close.
Yes, it was in Memphis, Tennessee at 10:18 a.m., which is the future.
There, Tennessee. Okay.
Yes, yes.
So we should have resume the box delivery like next week if the case arrived this week.
Yes. Yeah, so we started building. We got 7 motherboard, CPU, RAM units tested. We have all the GPUs ready. So it's just the case. But yeah, boxes should go out this week. Boxes should go out this week, and we should then be able to build like another 10. And then once we have 10, I'll send out the email to the mailing list, and I think they'll sell very quickly. I mean, I know if I was buying something like this, I would wait till it's actually in stock.
Yeah. Then if it sells quickly, do we need more cases?
Well, okay. So we ordered 40 cases. We have 20 coming in the DHL, 10 coming in the DHL, 10 coming by FedEx, and 20 by sea that will be here July 5th.
July 5th. Okay.
Yeah, so we can sell 20 in the next 2. No, we should be good.
Okay, sounds good. Okay. We're still selling red.
We sold 2 reds. And I'm 80% sure we sold them to the government. So the government has been sending me emails through various different things trying to buy these. And of course I tell them, no, I'm not filling out your supplier portal. I'm not, oh, but you just need to certify that this is made in America. I'm like, bro, I'm not certifying anything. Okay, but the least you can do is send us a W-9 and we're going to deliver a check to your office. I'm like, no, you have to use the website. So they eventually, this company bought it that looks like a front for the government, or at least someone the government contracts with. So I'm going to guess what happened is the government bought it through this company, and then this company is going to charge the government an extra 20 or 30% using their process.
Interesting.
Because who else is buying 2 red boxes? But no, we legit sold 2 red boxes, and they sent the wire, so they'll ship today. So yeah, 2 red boxes left.
Oh, only 2 left?
Only 2 left, yeah, and then that's it.
Just realized Green V2 has exactly double the flops than red.
It's exactly double?
Oh, that's what we... no, more than double, I guess. Slightly
Well,
more
so
than double.
yeah, I mean the Green V2, originally I had a smaller number for the flops because I was going off of Nvidia's datasheet. But Nvidia's datasheet is just it's just funny that I've never seen a company underpublish what the card is capable of so much. That 1492 is actually what it tests to. I don't know if it's like boost clocks or what it is. But yeah, the red one is actually probably a little less than that. I'm not sure you can actually get that number. Yeah, I mean, I don't know. It's you need like a canonical way to measure this. There's flops, there's gem flops. But yeah, no, I think that the way we should measure it going forward for all the tiny boxes is whatever we can actually achieve with something like MMA Peak. Similarly with RAM bandwidth. Found all these instructions. Yeah. You have to build it. You build this benchmark using this special compiler, and then it gets high RAM bandwidth.
Yeah, you also need to kind of disable some cache, maybe.
Yeah, no, there's a bunch of kernel config things you can set, and it makes it faster.
Okay. Sounds good. Let's move on to your Testgrad.
Yeah, so I think I'm making pretty good progress there. The big difference between Testgrad and Tinygrad is Testgrad has no kernel.py. So yeah, kernel.py. I mean, kernel.py is one of the oldest pieces of code in Tinygrad, and it pushes a lot of complexity into the scheduler, where this complexity should just not be. So currently in the scheduler, we can move views left and right. But there's no actual reason to move views right, except for the fact that kernel.py needs them to look a certain way. So the new scheduler only has view left. It's the same view left that's in the other one. And then all the views just pile up on expands. And then and we can see if this can go in Tinygrad, but the key insight is that reduces make shapes smaller. And the axes, like if you an old reduce that would go from like 30-30 to 31, the 30 in position 1 and the 1 in position 1 are not the same axis. Even though they're the same position, they're not the same axis. And this is more elucidated in things like, imagine I have something that's 30-30 and 30-20. I'm reducing both of them on axis 1, giving two things with a shape of 31, and then I'm adding them together, 30, 1, and then I add them together. And that's correct, except currently, kernel.py can't express this, because the input shapes are different. The input shapes are 30, 30 and 30, 20. So yeah, that's basically why kernel.py has to go. There's all these hacks in the A-range fuser right now to detect this case and not fuse those A-ranges. But there's no reason at all you can't fuse those A-ranges. So yeah, the new one just doesn't have any of this. It's very simple. Fuse A-range is the default. So yeah, it's probably going to be a few more weeks to actually get this integrated, because with no kernel.py, we have no opt-ops anymore. So yeah. I have to add the opt-ops back in, and I'm adding them in a much more principled way, where like every opt-op is pretty much doing some form of range splitting. So you can just apply that to a graph. You can just create the range node in the graph and then split the range how you see fit. Like if you want to do an upcast on an axis that's 32, if you want to do like an upcast 4, okay, great. Now it's a range of 8. That range of 8 times 4 added to an upcast of 0, 1, 2, 3. And you could do that as a rewrite rule instead of as a out-of-band kernel.py thing. So it's really simple now. Like, if you look at what's in CodeGen and init that does the kernel code generation, there's basically going to be another one of those for the big graph generation. And then it's relatively simple. I also want to make sure one of the goals of Testgrad is that it can generate all of MNIST in a single, all of beautiful MNIST in a single function, and I want to remove CPU graph. So like, there's no reason with the CPU that you can't render the entire graph into one function. And like right now, the only reason we can't do that is because of like, just like, it's unclear exactly how to even specify that. I want to make sure there's a clear language to put huge things inside a single function, and this works on the CPU because there is no G and there is no L. Right? There are no global loops, so yeah. Just being more clear about when loops end, when loops begin. This fixes the reduce thing as well, so I have a clear language for it. I just need to make it all work.
I see. And how do you, in the new world, how do you group kernels? Like
What do you? How do you decide what's in a kernel?
How do you decide when you need to split a new kernel? So everything can be in one kernel presumably, but then you, for different reasons, you might want to split into a smaller one.
There's a distinction between a global. So we still have the G barrier instruction. The G barrier UOP is the same as the barrier UOP, except it applies on a global level. So for the GPU, G barrier means a new kernel. For the CPU, all it means is close all the loops.
Oh, I see. Okay.
So yeah, it'll just close all the loops, and then it'll write that out to a thing, and then that's it.
Oh, so on CPU, there won't be more like kernel splitting. It's always like one big kernel.
You can do it that way. Like right now, it still has the same logic, but I can write whatever as the logic.
Yeah. That's
there's advantages to kernel splitting because of deduping. So right now, the deduping still occurs at the kernel level, and it might always occur there. Yeah, if you're calling the same, like, right? Because like imagine rendering a transformer, it's going to render literally every layer as separate code instead of calling into the same things. So, like, there's advantages to this hierarchical structure, but I mean, really, what you want to do is you want to put a range UOP in the overgraph to deal with the layers. If I have an LLM with 10 layers, that should be a range. Okay. But yeah, no, it's good. It really clarifies like what these things mean. So what G barrier means is close all of the loops. In the same way, barrier is basically the same thing. Barrier means close all of the light blue loops. G barrier means close all of the blue loops.
Close as in sync, like wait until every loop is done.
Yeah. So in C, you can think of it as closing the loops. On a multi-threaded machine, you can think about that as a sync. Like you see, it just basically means that like, yeah, you're ending the scope so that this entire array must be materialized before you can move on to the next instruction.
Okay, makes sense.
Actually, that's interesting. Maybe it should just be one barrier instruction that says up to what axis number you have to close. Right? So like G barrier would be barrier 0, and L barrier would be something like barrier 2 or 3. But I don't know.
Okay. Anyway, that sounds like good progress. That's it?
I think so, yeah. I mean that's basically the only change. So this week I'm gonna figure out how to start adding ops back in. Having the kernels. Also beautiful MNIST doesn't work. I still have to look into that. All of the ops tests are passing except for the ones with zero shape. Which I have to think about what that actually means. Yeah, I think those are things where we basically like we have tests for it, and then we just put hacks in a few places to deal with it, and it should just be dealt with in one place.
Okay. Sounds good. Okay, let's move on. So we may or may not have Llama 405B. Something I already tried before was to add grad accumulation to BERT. I think we are interested in making sure this works anyway. So I plan to add that to BERT and to Tesla, which means something about BERT needs to be fixed. BERT is using 3x the memory now. Not exactly sure why. So that was my plan this week to fix, or at least to understand what's causing that and see if it's like.
No, we definitely have to fix BERT. I mean, it's just a question. Look, if we don't get the AMD contract,
We are still going to work on BERT and submit BERT next run anyway.
Absolutely. And what I'd really like to submit for BERT next run is training on multiple machines.
Great.
Yeah, multiple machines. Let's figure out what the right gradient accumulation is. Maybe we can start doing big steps. A lot of those tricks still make sense. It's just like, I don't want to deal with like AMD's weird hardware and
yeah.
I don't know. It's a shame. It's a shame how difficult. Again, like, why don't these companies just make it easy? Like, do you want to do this or not? You know?
Okay, I don't know. We'll see if that goes through. On a separate note, I want to see if we can run Llama 405B inference. So I think what Perry was helping me download the weight on MI300X machine. I was hoping I don't know if the memory bug is there, but it should be fairly easy for us to like split into a GPU and just run a few tokens. That's it. With that, we can move on to Viz tooling.
I think I got one round of review from you, George. It's in a good spot. I tested on a full BERT run and it was pretty responsive. I'm thinking we can merge it. It's a little more lines than the UOP is because I'm not using any libraries and stuff. It's just literally a
So,
bunch of dollars to do it.
I mean, to ask the question if we can merge it, right? So I really like that it's the default, that it just shows up. Are there any downsides? Right? Like, I don't want to have a flag to turn it off. We have to move away from flags. So it's
No overhead.
no overhead.
Pure-
So, great. Yeah, I'll test it today and give you some more feedback.
So I'll wait for that before merging.
Cool.
Yeah,
How many
I had a
how many lines is it?
153 lines of JavaScript.
53 lines of JavaScript. Any lines of anything else? Or just JavaScript? It's not too bad. Cool. Yeah, I'll test it out today. Oh, and also, wait, did we delete Perfetto?
Yes.
Okay, it deletes Perfetto.
It doesn't. It deletes the button. You can still go to /profiler and
Do you not feel 100% comfortable deleting Perfetto?
I do actually.
Great. Then let's delete it.
Okay, alright, sure. It's fine. I'll delete it. I did last minute just made the Perfetto UI match exactly with the flame graph style stacking. That looks good, but
Do we have
it's
lines
not
like Perfetto?
lines on the grid, you mean?
So in Perfetto, when you click on a kernel, there's lines connecting to like what its dependencies are.
No.
I would play with Perfetto a bit more and see if you're really confident that we've 100% replicated the features of it. And then for every feature, I'm not saying we have to replicate it, but for every feature, you should say, okay, like, this is outside the scope. This is something we should have too.
Perfetto has a lot of things, yeah.
Yeah, Perfetto has a lot of things, right? Many of which are useless for our case. I mean, my biggest complaint about Perfetto, and the main reason I never used it, is you'd click on it and it would take 10 seconds to load.
Yeah, this is much faster.
Sweet. It's also not always on. Like, the minute you put something behind a button, nobody clicks it.
Okay.
Yeah, just for giving it out there, anyone can go viz equals 1, test it. The first thing that opens up is this graph. And run some beautiful MNIST or multi-GPU if you want. And,
I will also test it. I'm very interested in this.
Yeah, great. Yeah, let's get this on BERT and ResNet and see if we can see what's slow.
Oh, so the BERT thing you posted was not with beam search, right?
yeah, just pure BERT.
Oh,
Exactly
okay.
what we have.
So that R is probably just a bad default.
Probably.
And then we probably want to move the memory graph there too. I think it makes more sense to have it in a.
I think so too, like a shared time access, and then you'll have everything.
Yeah, but no, I think we can totally let's get it merged before then. Let's first replicate Perfetto and then think about what more features we want.
We'll add the arrows and stuff that show the dependencies.
I mean, or you can say we don't need it, but either way, we should. For every feature of Perfetto, we either need to say, yes, we're going to build this, or no, we don't need it. I remember the arrows being kind of useful. I remember the arrows just kind of showing me, oh, hey, it's that's where this one's coming from.
Yeah, and I think for specifically this, maybe just open an issue to track like the features you already decide to add or not to add. So people who have experience with Perfetto can take a look and add it, like comment on anything if it's missing.
That's good.
Cool. Nice. Let's move on to drivers.
Yeah, I'll also add a bit to Perfetto. And dependencies, I think we might want to change style because it's really annoying to generate dependencies right now for Perfetto. And yeah, if we like implement something similar, we can definitely just make it a lot simpler. And
Great.
yeah, so currently dependencies are only visible in graphs, so you need to run NV or AMD to see them. Yeah, so yeah, finished with NV driver. I mean, like we got compute GPT-2 working right now. So the missing thing was graphics context, and I spent quite a lot of time on this. So yeah, but now it works. So yeah, this week we definitely will merge it. I've tested and it looks fine on Ada.
Great. Any progress on copy out speed?
I don't really know.
Yeah, we gotta get that done. We gotta improve the copy out speed and then profiling on the comma devices. Figure out why the USB is slow because comma can't really use it yet.
Yeah. Okay.
But cool. No, glad Nvidia's almost done. And then, yeah, hopefully, I think there's also some time to spend just refactoring the general driver stuff and HCQ stuff, making sure like everything's in its right place. Hopefully the Nvidia driver will force some good refactors. Like a lot of the PCI interface stuff is fairly generic PCI stuff, but then there's a bunch of hard-coded AMD stuff. So ideally also that this is done. So I always prefer instantiation over inheritance. Like you have a choice when you have something like PCI interface, right? You can either create a class that has an object inside the class called like interface, which is PCI interface, or you can override PCI interface with AMD PCI interface. I think it's generally cleaner to do it in the style of you have something like AMD device that instantiates something called PCI interface. I think that lends to better abstractions. But yeah, no, I think once Nvidia's merged, I could sit down and do a review and say like, yeah, I think we should clean up a bunch of this stuff. I think a bunch of the HCQ stuff is kind of like this too, where there's lots of overriding. Well, there's lots of inheritance. There's lots of like HCQ device is being inherited by the AMD device and the Nvidia device, and it makes it kind of confusing to track through like, okay, what really needs to be implemented here. Like overriding a class is fine if what you're doing is you're adding like a bunch of parameters to it, or like, you know, 2 clear 10-line functions. But when you have one 600-line class and then you inherit that class and then make another 500-line class, that's pretty unreadable.
Yeah, I see. Yeah. Yeah, I think this week a lot of refactors for NV.
Cool. But yeah, no, if you have like the 600 line class and the 500 line class, that's fine. I'd rather the 500 line class, instead of inheriting, creates an object. AMD device creates an object called PCI interface. And then that object can be reused by Nvidia.
Mm-hmm.
That's it.
Yeah, that's it for me.
Great. Is WorkSpirit there?
Yep.
Okay, your stuff.
Hoping to get something up for file system this week. Mostly just working on like file system manager right now, because currently we need something that when the user uploads a file to it, like chunks it and then determines like which machine each chunk lives on. I don't know if S-Likes is here.
What, you want to talk about the symbolic expand? Do you need
it's
it?
not just symbolic expand. A lot of stuff. I think so. The other thing is our current symbolic seems to not support like what exactly with variable batch size is doing. Because our symbolic is very shaped around how the LMKV cache works.
Okay.
Which is a lot of shrinking.
Okay. So I think the best way to proceed is probably also open an issue or add some tests or like things you think should happen. At the same time, I don't believe like variable batch size will block you. I mean, you can just use variable explorer.
Yeah, I think the test is the way to go here.
Yeah.
Just write some small tests. And...
Okay. That's it.
Okay. So these two symbolic, similar stuff. I saw he had a bunch of PRs this morning. I review it already. So I think the primary one big thing here is integer division is pretty annoying, and I think before we add more rules to like I think adding rules to fix stuff or like removing rules to fix stuff is always good, but before we add yet another bunch of rules, we need to decide like what's the division, like which version of division we want to use and what's the reason for that. And even if later we want to do the transcendental style rewrite ourselves to define the div behavior, we still need to decide and hopefully unify the divide Z3 is using, the divide Python is using, and it seems to be the cdiff that the current device is using.
Yeah, agreed. I think we should probably look into read the RDNA3 spec, and we should look into what the hardware actually supports. And whatever the hardware does is just what our divide should be.
Sure. I mean,
Or
there's an argument being made that your IR might want to use a different one because it simplifies better.
Yeah, okay, and then do a late rewrite to write it to be the one the hardware does?
Yeah, similar to what we are doing with the sub, right? It's like we use add because that rewrites better.
Yeah. Okay. No, good point. Yeah. I'm okay. I'm open to that. If there's one that's clearly better, I guess. We should.
Yeah, for now we kind of treat it as a lot of one-off case just because we don't have a good understanding, and I hope this project would help us understand this better, make an informed decision.
Great.
Okay. I work with him. Let's move on to Onyx. So we merge the parser. That's great. Was that Bounty Clan? Because I saw it's still yellow. I don't know if yellow means not paid or question mark is green.
I think it's good to mark as green, though I do see some crashes sometime. I see some seg faults in Onyx, and I don't know why.
Yeah.
I also see that Onyx runner.
I think sometimes maybe auto memory or something.
I see this PR that says Onyx runner file as an input. Do we still need this? Need true spec parsing. I don't know what that means.
Oh yeah, that was my
Yeah.
and just got the reply.
Yeah, I don't understand why this model proto runner is being imported. I don't think it should be. This should just be Onyx runner should take in a file or a tensor the same way the rest of them do. Yeah.
Yeah, so I think let's go for this PR.
Great. A little bit closer to getting Onyx copied into the main.
The most recent Eval VM error out in metadata. Okay, interesting. Okay. I would check the Onyx runner file thing again, and hopefully that should unblock you from like all other Onyx stuff that we are excited about. Okay. Do we have anything for local?
Hi. Hello. Yes,
Hello.
I've been mostly working on still the masking problem for shared buffer for shared buffers. I kind of identified 3 different issues. Like one, for example, being when you want to promote something to shared memory, you don't want to you want to keep the access broadcasted. You don't want to expand it and share to shared memory the repeated events. So that right now, access is just only as one element in the shared memory, but the program access there's mask in that access, and the mask is not propagated correctly. And for example, with reduces, there is one case that it might propagates an if gate in that case, but it's kind of manual, and it's also brittle, and I think it's the cause for many that's failures in beam search. And well, that is only for one case, but for shared memory for like generic LDS, there are many cases of that. So that's one issue, and I think like I have 2 main concerns. One main concern is that I don't know how useful it is to keep working on this, as it is not clear how much this whole infra will change in the near future due to the work being done in Testgrad.
It shouldn't change much. I mean, sure, the actual implementation will change, but the tests won't.
Yeah.
Like whatever logic you put in there, if the logic is good, I'll just copy and paste the logic into Testgrad, right? It's the same thing with tensor cores. Like tensor cores and locals will not be in. So right now we have this function called get modified AST, which is basically like a hacky form of a graph rewrite. what I'm going to do for Testgrad is just move everything that's in get modified AST into rewrite rules. But like, it's not like the logic will change. So like getting locals working in Tinygrad does not have to wait for Testgrad. I will just copy and paste. If the logic is good and well tested, I will just copy and paste that logic into a rewrite rule instead of into a function, but it's the same thing.
Okay, cool. So then I kind of talked a little bit about the issues here, but I'll post more findings on this masking issue later today, like as progress report, because I think there are some interesting things to be addressed. So yeah, if it's useful to keep working on this, I'll keep updated.
Yeah, so I think it's definitely useful. We definitely want this feature more down the line. The best way is the same as you discover the issue, you discover the kernel that would trigger the issue, add it as a test so that we know we know if we are correct or we are incorrect.
Yes.
Linearizer might change, and for the better part, it probably fix some of the bugs for local and like mask. Some of this is probably just hack around because we didn't have cases like this. So
no, I think most of the issue arises before linearizer.
Okay.
But yes. Well, some minor thing that I didn't knew how if it was worth also upstreaming because of this change in the optops is that upcast I think it should be reserved for global DIMMs. Like upcasting a local DIMM is the same as upcasting a global DIMM, but with extra steps, and it does reduce the search space significantly. But it unfortunately also decreases the speed of some kernels found. As upcasting a local DIMM right now is a way of breaking the locality of the beam search like algorithm. It allows it to perform like optimizations in
so it's like
earlier.
It's like you upcast twice, then you do a like swap on those two. Probably the same effect. Compared to you first upcast a big chunk and to local, then you upcast from part of it from that local.
Yeah, I think it's equivalent, and it's if you don't upcast locals, you can arrive to the same kernel but with fewer optops, so it does reduce the search space. But given the search algorithm right now,
you're just going to have to test that, and we're going to need some way to test that, right? Like, they're totally equivalent, right? It does not matter if you upcast a global DIMM, then local a global DIMM, like upcast for local 32, right? Or you could also local 128 and then upcast 4 on that local. And those two kernels are equivalent, but just because the end kernels are equivalent doesn't necessarily mean that the search space is amenable to finding it. So I'm open to changes like this, but we would need a way to benchmark it. We'd need a way to say that, the search hits just as well and it searches less of the space, right? Just saying like they're equivalent, therefore we should only do it one way. I mean, you can't assume that you have a perfect search algorithm.
Yeah, but
that's the issue.
I think it's more of, so we had been doing this for a while. So if you can show that it's not off by too much and it indeed reduced the search space, I think that's more preferred. It's not like we are on the line of like we have a frontier of search thing that we want to maintain. As long as the memo looks fine, the bed size one transformer looks fine, like
No, but that's what I mean by a test suite, right? Like we should just make sure that we're doing fine on all of those. But yeah, no, I would think that what you actually most of the time want to do is you want to, like, you have a global DIMM, you first want to locals it, and then you want to upcast again on top of that. because the best way to memory coalesce is across the locals. So my guess would be, thinking about it more, it's actually the other way. It's not that you, yeah, I'm fine with if we test it on what we have, I'm fine with not allowing upcast on locals.
Okay.
If you think about the,
Go ahead.
if you think about the DIM globally, the thing that you actually probably want is globals upcast locals.
Yeah, because you can decide, you kind of start from your upcast, right? That's your kind of a minimal element in your compute. So you start. It's hard for search, but you really want to start from that, then build.
Wait, no, I think you want to start from locals.
Yeah, I think you want to start from locals too. I mean, if you start from locals, your threads are contiguous, right?
Yeah. Yeah, you want your memory to coalesce as much as possible. So the ideal first step in most kernels should be doing locals on the thing that's stride 1 or the closest to stride 1.
I see.
Which is, yeah, I mean, it's kind of,
if you upcast first, you can vectorize, right?
well, it's kind of counterintuitive. Yeah, it's kind of counterintuitive. Like you usually think, actually, no, this isn't probably, no, wait, no. I'll correct this again. It depends on your D type. So if your D type is float, you probably want to do locals first. But if your D type is half, the first thing you want to do is upcast, without a doubt.
Upcast
Because
2.
you want to upcast 2. Yeah, the first thing you're going to want to do is upcast 2. And see, that's the one that might miss. Because the locals has a much stronger pull. Yeah. Okay. Yeah, I would guess for half that I bet you that's what, I mean, yeah, what we really need to do is just have a way to like say, like, okay, is this happening? Right? Like, what's the path taken to search? I wrote some tooling around this, but it wasn't very good.
Yeah, so you can there was a test somewhere that tried to do the beam search on kernel datasets and like count some stuff.
This'll be fun visualization tools to write. We need to write tools that show how the search is happening. Yeah.
Basically a way to have a script or tools that shows these hypotheses are indeed happening for search. That might also give us a better ideas for like how search should improve.
Yeah. I wrote some like bad graph tooling around it, but it would be great to get this integrated. Maybe that'll be the project after TimeVis. Search Viz.
Oh, thank you.
Okay, thank you.
Okay. Other bounties. I don't know if we get any update for RetinaNet.
Oh, hello. Yeah, so I've been still working on the eval itself. I think I'm halfway there. It's just like I'm trying to find equivalent Tinygrad operations for I think, well, unique I figured out already. But there's some other ones that I'm still trying to figure out. So I've been just updating my draft PR over time to make those changes.
Yeah. If you have the chance, you can also post some of these in the channel. I think similar to the moving CFAR to Tinygrad one. I think there are some stuff that we currently don't support that good, and it's also not clear like how to write those, and we might want to improve those, either like adding a corresponding tensor function if we don't have it, or because we expect people to like rewrite these torch code or equivalent to Tinygrad. So any blockers that you find would be helpful for us to improve.
Okay, sounds good.
Okay. LM eval. I don't know if FanCat can talk here.
I don't think they can.
Who?
And cat.
FanCat, you're added as a speaker. If you have to exit and re-enter the voice chat if you want to talk.
Okay.
Great.
For Eval,
I mean, you don't have to talk. It's totally up to you.
SGLang is quite different. Their prompt is different, but it seems they're prompting for a reasoning model. It seems a little unclear.
Oh, I tried to use Llama this weekend. For a project I'm working on. Yeah. We can do so much better. The most annoying thing, the thing that took me forever to realize, is it was like catting a file into it, and the default context length is 2048.
Oh yeah, people complain about this all the time.
And then there's no environment variable to set it.
You have to edit the Llama file.
Yes. Which is crazy. And then eventually I do it, and then it just starts taking forever. There's no, I update the context to what the max context size is of the model, and then it's just sitting there hanging for 3 minutes, and I'm just like, wow.
No, Llama's pretty bad.
There's no update on. There's no progress bar. What is this doing? How many tokens is my file? How come it doesn't tell me this? Yeah. So I think there's actually
Llama's pretty bad. If you use just base Llama CPP, it's better. It's just more annoying to work with.
Base Llama CPP.
Yeah, because Llama is just Llama CPP.
Oh, I didn't realize that.
It's the same thing.
I mean, it's nice.
Wrapped it into a nice.
They make it very easy to fetch models, but then you fetch models, and then
other models are out of date as well.
You fetch a model, and it doesn't tell you anything about the quantization of the model. It's just called Quen32B.
If you fetch DeepSeek R1, it just fetches the 8B version. But it's called DeepSeek-R1.
Wait, what do you mean the 8B?
It fetches the 8B version.
Oh, the 8 billion weight?
Distilled into Quen.
Yeah. Yeah. I don't know. I think that we can do a lot better with this, and we could become, if someone wants to put effort into this, the default way. Just pip install Tinygrad, and then it'll run any LLM. It'd be great also to be able to, if we could fetch from Llama's HTTP. Yeah, like the model repositories or Hugging Face, because that's okay, why am I using Llama? Why am I not using Tinygrad? Well, we don't have an easy. I just don't even know how to do it, and this is we need to. So I don't know. Back to Tinygrad/apps.
Okay. Anyway, so back to that bounty. I think we just want some comparable stuff. So
so I think we just copy SGLang. Whatever SGLang is doing, I think we just do that.
Okay. Anyway, for FanCat, I hand this the validation of the bounty towards Parrot. So just let him know if you have any questions. Great. AMD VM, I merged the default to using AMD VM, and I think on at least on ResNet, because we update LLVM version to 20, that seems to be faster compared to our old time with AMD. Slightly, 1% faster, but still slightly faster. Well, that's pretty nice.
Interesting. Because ROCm is LLVM 21. LLVM is faster.
But I also heard ROCm 6.4 is faster.
Well, 6.4 would be 21. I don't think 6.2 is 21.
Oh, 6.3 might not be
20. Yeah.
Yeah.
We should try that one too. I mean, it's nice that we support both, but overall, it's just so much cleaner to just have it be LLVM.
ROCm 7.
It's real. Oh, it turns out also, I was engaging with some guy on Twitter. There's an open source SAS compiler now.
Yeah, the one
in Mesa. Yeah, Mesa has their own UOps called NIR. So there's a bounty for that if anyone's interested. If anyone can get that wired up.
I think if you do that, it'll support AMD, Mesa's AMD output as well.
Yeah, it'll support the ACO one. Yeah.
Yeah.
Yeah, I think so I called the bounty both of them. You could do either one. Yeah, I'm curious how performant that is.
Pretty decent, I think.
Yeah. And then even more, we need the infrastructure to support the separation of device and compiler. But
who is working on that?
I'm working on it. I'm working on it. You have to delete CPU graph first. CPU graph breaks this. CPU graph breaks the whole thing. The refactor itself is very mechanical and easy, and I will do it once we feel good removing CPU graph, which maybe I'll just do today, and just say, okay, we're going to comment out the DSP.
Yeah, no one is using CPU graph now, so
yeah, no, yeah, okay, great. I'll just remove it.
CPU graph breaks some stuff.
CPU, there's a special rule in remote for CPU graph. Like, it's just not.
No, because like
it doesn't look like the other graphs.
There's an open issue right now. A lot of stuff when you try to run it on CPU without j equals 2, it just doesn't work.
Oh, great. Yeah. Okay. Well, it just got deleted. Great. Best code is no code.
Great. Okay. Second time we say goodbye to CPU graph.
Nope. It really doesn't want to exist. No, I mean, the real solution to CPU graph is something that looks like a runtime. It's something that looks like a GPU-style runtime implemented on CPU. That does like hyper-threaded dispatch.
Mm-hmm.
This will also be Tinygrad's answer to multi-threaded. Like, yeah, if you have a CPU with 32 cores, there's no reason that we can't use it the same way you use a GPU with basically 32 cores.
Oh, so it would be a multi and threading dispatcher, I think.
Yeah. It'd be a threading dispatcher, right? It's not like multi GPUs because the CPU does have a unified memory space. But it would be the same way the GPU, when you have like a G dimension, how it dispatches them to all the compute units on the GPU. Well, we can write basically that on a CPU, and that will also be the answer to CPU graph. We have to basically write like a PM4 parser for CPU, or determine whatever thing we want to use. And then like we have like a CPU command queue, and then the CPU command queue is parsed by something that's running on every thread. That's like the right way to do this.
Great. Okay. Lastly, so UVM is not here. Was Perry, you have anything to say for?
I didn't get to looking at remote multi-hulls last week, so I'll do it this week.
Okay. Just making sure it's not blocked on us.
We have something that we should be reviewing now?
You can look at basic remote multi-hulls. Yeah, this one.
All right, cool. All right, so you got this?
Yeah.
Great.
Looks okay. I don't know about the format for specifying the hosts. It's verbose, but I don't really see a better way to do it. If you look in the test, like you have to do this. You specify like one device times the amount of devices on that device.
Where?
At the top. Yeah, right there. Yeah, you specify like this host.
Wait, that seems great. I love that. What?
No?
You want to do that? How do you want to do better?
I don't know. Yeah, that's what I mean.
That's actually super nice with the tiles.
Yeah. Okay.
Yeah, I like it. I mean, how else are you going to say that there's...
Yeah.
Right, you have to
see another way to do it.
I mean, you could connect and query the devices, maybe?
Yeah, that was my thought. It's like you don't actually have to specify how many devices are on it. You just specify the hosts. Like, no, I don't see any other like multi-framework that...
Well, no, but I actually do kind of like that because you could say, like, okay, I want to put on 4 GPUs there and 4 GPUs there. Yeah, I like this better. I like it better specifying on the client. Yeah. It's syntax. I'll put
the formatting.
Yeah. It's just having. It's the way you specify how many GPUs there are on the remote machines, and these are doing like times 6.
Interesting.
Well, you could also say that, like, okay, we'll have it just query the number of GPUs from the process, but then, I don't know. This is fine. I like this. It's also something that can always be changed.
Yeah.
Okay.
Great.
Cool. Sounds good. Okay, that's it for this meeting. Thanks, everyone. See you next week.
Thank you.